Hi, this is Alex from devstories.eu. Deep Agents, Episode 7 of 16. Letting an autonomous system blindly run SQL queries is an excellent way to accidentally drop a production database. If you want your agent to operate in the real world, you need a mechanism to intercept it before it does something destructive. That is where human-in-the-loop interventions come in. The core idea is simple. You pause the agent right before it executes a sensitive operation, ask a human for direction, and then resume execution based on that feedback. Before we look at the mechanics, there is a common pitfall to avoid. LangGraph requires memory to pause and resume state. If you try to configure a human-in-the-loop intervention without setting up a checkpointer, the intervention will fail. The system needs a persistence layer, like a memory saver, to freeze the execution graph and store the current variables while it waits for a human to respond. Always attach a checkpointer first. Not all tools need human review. Checking the weather or reading a log file is generally safe. Deleting files or altering database records requires strict control. You handle this risk categorization using the interrupt-on configuration parameter. When you initialize your agent or define your tool node, you pass a list of tool names to this parameter. If the agent attempts to call a tool that is not on the list, it runs immediately. If it tries to call a tool that is on the list, the execution pauses. Let us walk through a concrete scenario. You have an agent with a database tool called execute. You add execute to your interrupt-on list. The agent decides it needs to clear out some old data and attempts to run a database drop command. The system intercepts the call and pauses the execution graph. When you run your agent, you monitor the result object returned by the framework. Specifically, you check for a property called interrupts. If the result interrupts list contains data, the agent has hit a safety gate and is waiting for your input. At this point, the human operator evaluates the pending action. You have 3 allowed decisions you can pass back to the agent. These are approve, reject, or edit. If you approve, the agent executes the tool with the original arguments. If you reject, the tool call fails gracefully and the agent receives an error message prompting it to try a different approach. This is where it gets interesting. The edit decision allows you to modify the agent's intended action before it happens. In our database scenario, the agent is attempting a dangerous drop command. You can intercept that request, rewrite the tool arguments to run a safe select query instead, and send that modified payload back to the system. To unpause the agent, you invoke it again, but this time you pass a command object using the resume parameter. Inside that resume parameter, you provide your human decision string along with any modified arguments. The checkpointer retrieves the frozen state, injects your human decision directly into the graph as if the agent had originally planned it that way, and execution continues. The most important thing to remember is that human-in-the-loop interventions give you more than just an emergency stop button. The ability to edit tool arguments mid-flight allows you to safely guide an agent through complex workflows without starting over. If you want to help support the show, search for devstories.eu on Patreon. That's all for this one. Thanks for listening, and keep building.